Hello learners, today I start a series of quantum physics. What is quantum physics? That part of physics which explains how everything works in nature. In our daily life, we observe light turn to electrical current in a solar panel, electron transformed through a small chip, amplification in a laser, feeling of gravitation force. Then question come in mind, how it happens, how thing works in our real world. Definitely, you have to learn the use of quantum physics. Quantum field theory helps to describe the results of experiments at high energy particle research centers. Various phenomena like black body radiation, photoelectric effect are not explained by classical mechanics. Thus, quantum mechanics was developed to explain these phenomena. The mathematical foundation and interpretation of quantum theory developed by physicists like Niels Bohr, Einstein, Schrödinger converted quantum mechanics to quantum physics. Take a look on old quantum theories. First one is black body radiation. A black body is material that absorbs all radiation falling on it, and after heated, it emits radiation known as black body radiation. Here the power density variation with respect to wavelength at different temperature is shown. As temperature of body increases, the maximum value of intensity shifts towards the shorter wavelength. Area under density versus wavelength graph represent the total amount of energy emitted by black body at a given temperature. It is clear that the total amount of energy emitted by a body increases with increase in the temperature. From simulation results, we can say wavelength is inversely proportional to the temperature, or wavelength into temperature is equal to constant. Wind displacement law give its value equal to 0.298 into 10⁻²⁻² meter Kelvin. According to classical concept, Rayleigh-Jean law describe energy is inversely proportional to lambda's power 4. But this classical theory fails to explain that energy emitted by a black body also approaches to zero as the wavelength of the black body approaches to zero. Contradiction between classical and experiment data is known as ultraviolet catastrophe. To solve this mystery, Planck put forward new hypothesis called Planck's hypothesis. According to this hypothesis, a black body consists large number of charged oscillators of molecular size. Second one is the oscillators have certain discrete or quantized energies given by equal to nh nu. Third one is the oscillator emit energy only when it jumps from higher quantum state to lower quantum state, or it absorbs energy when it goes from lower quantum energy state to higher energy state. Solar panel is the best application of photoelectric effect. What is photoelectric effect? The phenomenon of emission of electrons from certain metal surfaces when it is exposed to light is known as photoelectric effect. It is observed by Hertz in 1887 when UV light falling on the electrode. There is production of sparks between the gaps of two electrons. Later on, Leonard and his co-workers explained that electrons are emitted by metal when it is exposed to ultraviolet light. In this simulation, electrode metal is sodium and three graphs which represent current versus voltage, current versus intensity. The value of current is decreases as we increases the wavelength, or we can say by decreasing wavelength, current value increases. Thus, photoelectric emission only starts when it have a minimum frequency which is known as threshold frequency. Second is effect of intensity of light. As intensity increases, the value of current increases. So, photoelectric current is directly proportional to the intensity of light. Frequency is more than the threshold frequency. Here I vary stopping potential at fixed wavelength. We see if we increase the stopping potential, current value becomes 0. In second option, we fix the value of stopping voltage, then vary the wavelength. Now I vary the wavelength, then current becomes again 0.
Similar results we can view in the case of barium. Here, barium. Third case is shown here for iron. Now change the wavelength. We see there is no current flow. From simulation, laws of photoelectric emission derived. First is, for a photosensitive material, there is a minimum frequency called threshold frequency. Second is, photoelectric current is directly proportional to the intensity at fixed frequency. The third is, photoelectric emission is instantaneous process. Fourth is, maximum kinetic energy of photoelectron is directly proportional to the frequency of incident radiation. So that's all about laws of photoelectric emission. In next video, we solve the classical and quantum theory of photoelectric and Compton effect.